So a client has reached out to me to ask how they can lock a very unusual door, in the sense that it's extremely wide, it's extremely thick, and it is hung on center hung pivots, just like you would have a revolving door. So the question that the client posed is that he's looking for a locking latch and what can be used. So let's switch to the screen view and let's take a closer look at what this door looks like and what the proposed solution could be. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. And here's the client's door. So first thing that strikes me as interesting is the width. I don't know the width, but the client doesn't tell us the width, but if each of these flitches is 8, 9, 10 inches wide, you've got a door that's pushing 4.5, 5 feet wide for sure. What I don't love about the design is the way that the veneer was laid up, because that definitely appears to be a veneered door. They may have specified just random matching of the flitches, meaning a flitch is a piece of veneer. Depending on the species of wood, flitches might be very narrow, like quartered white oak. You're not going to get a really wide piece of veneer because of the quartering process, meaning the way that the log is actually cut. Plain sliced is more like chopping an onion, so they can get wider flitches out of many species because the trees grow older or grow longer, so therefore they're larger. So this would be plain sliced, but there seems to be just a random match. I mean, this is just a figure of the veneer. As best I can tell. I'm wondering if that is a pole. It's hard to say. Anyway, so it's a really wide door, and like I said, it's hung on center hung pivots, or at least I'm assuming that it is. It doesn't have to be on center hung pivots, but it'll turn like a revolving door. Because of that pivot point, you can clearly see how far it is over. So the client's message is, we are looking for a locking latching mechanism to be able to install into the wall of this bar so that we don't have to modify our door too much. Attached our photos. We're going to have a 1/4 inch gap between the door and the jamb in this case. Looking around your site, it seems like there are a variety of options. Not afraid to use something powered either. Just need to evaluate the options. You can see the client says why we don't want to mess with the faces of the door. So there's the door. This is the wall it apparently is going into. And I like the idea of something powered because then you can have access control over it. You can control it with credentials, you can control it with access control software, and some sort of what I was reading from the client's message was less would be more. Some way to lock this or to secure it, but not do so in such a way that it takes away from the design of the door. This is prototyped and this is set up in a temporary structure in someone's shop. What concerns me a little bit, and this is one thing, that a service that we offer when we sell hardware, is don't know the thickness of the door, but that does not look like it's 1 3/4. And the reason I say that is because this is an unrelated drawing, and let's see if I can just quickly make up a drawing. Let's say that his door is 60 inch. Okay. Okay, so let's make this door 60 inch wide. Okay. And then we'll make the door. I'm going to guess that door is 3. Let's just say it's 3-inch thick. Go back to 60. And we're going to assume that it's a square edge door. And then we're going to go to 3, and then 90, then enter. Okay, so now we have a door. Now, let's put our pivot point right in the center. Let's put our pivot point at 30-inch. And because wouldn't say I'm the fastest when it comes to AutoCAD, I'm just going to put a line at 30-inch, and then what I'll do is I will get in here, line. I'm going to do this. And then I'm going to do this. Oh no, I'll do this. Circle. And this is just going to give us, a little better reference point on what our vertical axis of pivoting is going to look like. Okay, now let me take all of this, just move it. I'll leave that because that might be something important later. Not going to be important later. So now let's take, the client said that he had a 1/4 inch, so it's going to leave a 1/4 inch. This is going to represent our cased opening frame, our jamb, okay? No, I don't like that. Okay, so imagine that this is just a jamb, obviously. Now, 1/4 inch is what the client's telling us that they've got here, so let's take a look at that. Indeed, there's a 1/4 inch margin there. That's what the client's working on. 1/4 inch margin is what's in here. Quick. You can't see it because I'm too zoomed in. Here we are. 1/4 inch. 1/4 inch. Okay, so we've got something that emulates a jamb. We know that we've got a 1/4 inch built in here. That's all good. Awesome. So 3-inch thick door, we're assuming that. Now let's rotate this object, and this is I'm going to create a group. All right, so that should all be a group of objects. I'm going to select it. Now I'm going to rotate it, and I'm going to pick my vertical axis of pivoting. And here we go. We're going to rotate this. Okay, so a 1/4 inch does not appear to be too big of a problem. And it's with the help of AutoCAD, for a lack of the grasp of higher mathematics, that I'm able to have a client order pivot hardware and then tell them definitively what margin is required. And that's how it's done. So what I want to do is I really want to see if he's got a 3-inch thick door and what sort of gap he's going to have here. So throwing that out as far as possible, I'm just going to measure this distance. I'm going to get rid of our snap function and just kind of eyeball that. Yeah, it's 730 seconds. So, boy, it really doesn't encroach too much into the space. And in fact, I would argue that you could sure get by with less gap there. Because while that's not a lot of gap, it's also, you know, the jambs probably aren't perfectly true plumb level and square, so you do want some breathing room. But nonetheless, this would be a really good way to know exactly what's needed, and that's how we go about doing it. Anyway, these lines were just there for reference, so I can get rid of that. Yeah, so there's the client's concept mocked up. Let's take a look at his frame now. This is the second picture that the client sent us. That's what his jamb looks like. So apparently that walnut door is going to swing in this opening. You know, I'm not sure. Appears to be a couple of studs installed on their end up there. That could make mortising for the top pivot a bit of a challenge. And I don't know what pivot the client used. The client very likely used something not unlike the ABH 0370. This is a very common piece of hardware. We certainly sell this. We stock this. This is what is very often used in these types of applications. Now, my solution to the client was to avoid the door, as the client wanted to do. Now, you don't have to avoid the door at all, because there is lots of hardware that you can install to just not latch, but to secure the door. I don't think a latch is necessarily practical. You can certainly have a latch on the opening, but that's going to require a custom strike, to be sure. Given the potential thickness of the door, it's probably going to require a custom lock, or at least certain length cylinders. I liked the idea of access control. As I said before, I like access control. So what I've done in the past, when the client could not or would not, did not want to, for whatever reason, did not want to get into the door at all with any hardware, I have suggested in the past, and it's worked out really well, the STC series of electric deadbolts. So what I like about this series is it has a key override. So you electrically control it with low voltage. You can have fail safe or fail secure. Okay, and that's what's going to allow you to secure the door. You want to get in with a key or out with a key, you can have that functionality as well. I would probably think that this needs to be fail safe, so that it's locked only when powered. So if the power goes out, it's unlocked. If it happens to be locked, you've got a key option. Now, why would this work in the frame? Well, let me tell you why. And what we've done in the past is we have you know, let's say that this is a standard wall thickness, 4 7/8. You're going to install that bolt wherever you like. Let's just assume it's in the center, which would make really good sense. And I'm going to think you definitely want this to be fail safe, so that the bolt is retracted when there's no power, so that you can rotate the door during business hours and then close the circuit or energize it to secure the door, you know, when it needs to be secured. So you might say to yourself, well, how are we going to get these cylinders involved? Well, that's not hard. And what we do here is we would not only use, let's say something, sorry, 7205 SC1. So we would start with a standard mortise cylinder. Okay, this happens to be a mortise cylinder that's 1.25 inches. Well, when you look at this paperwork, that's going to be probably too short to get all the way through. So you're going to need a longer mortise cylinder, and we would have to determine what that is. It's probably going to be somewhere in the range of 1.5 inches, and in fact, it's probably going to be very close to what it would need to be. I would have to dig a little deeper to be sure if 1.5" would work. So what we would do is we would either find a cylinder that was 1.5", which we would be able to. Okay, there's an 1.5" cylinder. Let's assume that's correct. Now, if for some reason, let's say that that wall was 6" and now you needed a cylinder that was closer to 3". Well, that we're not going to find on the shelf. Now, what you could do, and what we do, is we custom make those cylinders. We would take that same 1.5" long cylinder, pardon me, 1.25" if I had that on the shelf, and then I would get into these components that we stock right here. So this company, Major Manufacturing, makes machined pieces of brass that allow you to extend the length of a cylinder so it looks like this. We do that frequently. Okay, so we can custom make pretty much any length cylinder you need, because you'll start with a base length of the mortise cylinder, 15/16, 1 inch, 1.125", 1.25", 1.5", whatever. And then you've got 1/2, 3/4, 1, and 1.25" long extensions. So we can get into making extended cylinders in this fashion, should that be required. So the client can get his power into the wall. Let's assume that there's power in the wall, and that he can drill, he can mortise the edge of his jamb once that's a finished jamb. And it does look like there's, well, that's probably tape. Drill a couple of holes for cylinders. What I would certainly want to do is find out what the greatest backset that could be done here. It's probably 1.125". I don't know if it's here or not. Backset 1.125" is definitely what it is. Or no, I'm sorry, 1.7". Forgive me, 1.7". Okay, so that would work. That's almost 2 inch. Now, if you didn't necessarily like that idea, another idea that I had would be something more like the Adams Wright product catalog, and that lock, the lock I'm thinking of might be a 2030 is what it might be called. Clearly not. You can see that I passed it, and coming around again. Here we go. 2331. So I like this lock, and here they kind of show it. Now this is 15/64. So 1 divided by 64 times 15. That's 0.234. So that's not going to be big enough in order for that to work. So you might need to, well, I would say in this case this would not be a good idea if you're going to have a 1/4 inch gap. If you were going to try to tighten that up, this lock may work, either in the door or in the jamb. But obviously you can just get yourself into the door, or again in the frame, just a hook bolt or a typical Adams Wright style deadbolt, you know, an MS security bolt. And here's a couple of them shown right here. Deadbolt, hook bolt, either of those would certainly work in this application. That's 13/32, so that's about 3/8 of an inch on the hook bolt, and that would certainly secure it. Again, custom like cylinders, mechanical lock, no power, very reliable, and this would work. Now, the other thing that occurred to me would be problematic, would be how to help center the door in this opening. It occurs to me that getting it to lock, you'd really have to be centering it very well. Well, the idea that I had on that, and I've seen it, and we've done it in other places, that would be something like here. Precision lock, extra heavy duty concealed magnetic catch with adjustable strength. So imagine mortising these two pieces of magnet into, well, you have positive and negative magnet. One in the jamb, one in the edge of the door. You adjust the depth of each so that it will help you center the door where it needs to be. And my thought was install a couple of them in the edge of the door so that when you put the door in the closed position, it will want to find its natural closed position, assuming that the center line of this is in the right location. And that could help the client get it to where it needs to go. The other thing that you could consider would be, and you would need a custom strike, but you can also do it at the header. So you could do a Rockwood 590 roller latch. Put that at the header. Now, let's take a look at the custom strike, and here it is. So they can make a custom strike based on the jam depth and then center that dimple area right in the center, so it will positively find center, and then you can have your bolt take over. Okay. I would probably want to think about a door position switch with a time delay on it, so that you can find center and then be done with it. That would be a bit more tricky. The ball latch, the ball that's here, that is to let the lock know that you're in the closed position. That projection can be tailored, and that may just work satisfactorily. It might be a bit cantankerous to have that, but that's how this lock knows it's in the closed position, because that ball, the state of the ball has changed, and now the bolt will come out because that circuit has been opened or closed, fail safe or fail secure. So that's where I was going with all of that. And I did ask the client if they would, well, let's just wrap this video up on camera and we'll make our final statements. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. So I did ask the client a couple of times to give me a call. He's a gentleman that we've done business with in the past, because I wanted to find out the details. How thick is the door? How did you arrive at a 1/4 inch margin? What is the actual width? What's the height? What pivot did you select? Why did you make those selections? How thick is the wall? Do you want to do something powered or not? And then hone in on the solution based on some of those answers. But the client, we're all busy. I get that. So this video is to just relay what a proposed solution may be for something not too terribly unusual like this, but a really cool look. And the walnut and the green, the longer I look at it, the more I think those two colors go together. Any questions on some sort of an odd application that you may have, please feel free to reach out to us. Thank you. Again, thank you for watching, and if you've enjoyed this video, please click thumbs up. Please subscribe and maybe even send the video to someone that you know. Thank you.